Okay, I'm going to show you something called the law of iterated expectation, or it's also sometimes called the law of total expectation. And so this is what this means. This law shows that the expectation of some random variable x is equal to the expectation with respect to y of the expectation of x given y. So this is kind of why it's called iterated, because we're sort of iterating over this conditional expectation. So the expectation of x is equal to the expectation with respect to y of the expectation of x given y. So let's show that this is true. I'm going to show it in the discrete case, but it turns out it's also true in the continuous case. So let's start with this part here. What is the expectation with respect to y of the expectation of x given y? So let's start with this inside part here, the expectation of x given y. So from what we know about discrete expectations, so expectations of discrete random variables, if we want to calculate the expectation of x given y, it's going to be the sum over x of x times the probability of x given y. Okay, so that's that inside part. And now let's wrap this in our expectation with respect to y. Okay, so now we've got that. Now let's take the expectation with respect to y. So the expectation with respect to y for a discrete variable, it's going to be done the same way. So we're going to now sum over y of the expectation of x given y times the probability of y. Okay, now I'm going to do something a little bit tricky. I'm going to switch the order of the summation, and I can do that because this is in this finite case. We can basically prove that this is possible, but that's why I'm able to do this switcheroo. So I'm going to do this switch where I take the sum over x of x, sum over y, times the probability of x given y, times the probability of y. So I did this switcheroo. These two things are equal. All right. So now, this right here, this probability of x given y times the probability of y. If you remember back to your probability class, what do we know about probability rules that this is equal to? So from the partition rule, we know that this is equal to the probability of x and y. So the probability of x given y times the probability of y is equal to the probability of x and y. And another probability fact that kind of goes along with that is that if you sum up the probability of x and y across all y, so if we take this whole piece, the sum of over y of the probability of x and y, that ends up being equal to the probability of x. So let's plug that into our equation. So we've got the sum over x of x. We've just replaced this whole part here by the probability of x. And what does this look like? Well, this is right back where we started, the expectation of x. So there you have it. The expectation of x is equal to the expectation over y of the expectation of x given y. This is a really useful proof. We're going to be using this fact when we're doing some various other proofs throughout this class, and so this is definitely one to remember.